Let's start with the topic, second part of my video. I'm starting with chapter 3, metals and non-metals. So in this, I would be starting from 3.2.4. So it says, how do metals react with solutions of metal salts? So we are reacting metals with metal solutions. So as you can see, there is a reaction between metal A and salt solution of B. That means we have two types of different metals. But in the first case, it is a element. It is a single element. Now, when I talk about salt solution of B, it is actually a compound made up of different metal. Now, if this metal displaces salt solution of B or metal B in the salt solution of B, then it shows that there will be a displacement reaction. Now, when it happens when metal A is more reactive than metal B. For that, you have to remember the reactivity series. Reactive metals can displace less reactive metal from their compounds in solution or their molten form. So as you can see in this figure 3.4, there is a reaction of metal with salt solution. So they have iron nail, that is Fe, and another is copper sulfate. Now Fe is more reactive than copper in the reactivity series. So there will be displacement reaction and displacement will form FeSO4 and copper will be released. So this is how the reaction takes place in the displacement reaction. So as you can see, they get copper wire and they get iron sulfate solution, same as what we get using the equation form. So if metal A is more reactive than metal B, then only they will displace. If metal A is less reactive than metal B, there won't be any displacement. So that's about displacement reaction. And you have to remember this reactivity series of metals to perform the above reactions or so. So remember this. Then we have, how do metals and non-metals react? So in this case, we should know all the valencies. So let's start with it. So we would be taking one metal and we would be taking one non-metal. So suppose I have sodium. Now sodium, as you know, has 2811, that 281, sorry. 281 basically means it has one extra electron with it. Then suppose I have chlorine. Chlorine, is actually 287, that is 17. So that means has 7 electrons. Now this one electron will go and fix here. So it will form Na plus and Cl minus, because metal has a tendency to lose electron and chlorine has a tendency to gain electron. Now chlorine gets stable. Why? Because has full electrons in it in the outermost shell, has a complete octet there. So therefore it is Na plus Cl minus. So if there is a gain of 2 electrons, then it will be 2 minus. If there is a loss of 2 electrons, there will be 2 plus. So remember this. Now, right? So as you know, magnesium has an atomic number of 2A2. Then therefore it has the ability to lose 2 electrons from it. Therefore they have written plus 2 electron here. Now Cl needs 1 electron to it to form a complete octet, or to form a chloride anion. So now in this case it will gain 1 electron. Chloride has a property, like chloride is a non-metal, so it has a property to gain electrons. So in this case it will be gaining 1 electron to form a octet at the last shell. So therefore you can see it is 288, that is a chloride anion. Now in this case magnesium has 2 electron, extra 2 electron. Therefore you must add 2 chlorine to it. So there should be 2 chlorine atoms, so that 1 electron can go to first chlorine, then the second electron can go to second chlorine, so that to form a magnesium chloride. Now in this case Mg as you know, it has gained 2 electrons, so it will be 2 plus, whereas for chloride it will be Cl minus 2. So this is like it. So now in this case, ionic compounds are those where we have transfer of electrons from a metal to a non-metal. Those compounds are known as ionic compounds or electrovalent compounds. So don't confuse yourself if they have written ionic or electrovalent. Electrovalent and ionic word is same. So either if you get ionic or electrovalent, that means it is the same quantity. Now, in this question, it says, can you name the cation and anion present in magnesium chloride? So, magnesium is cation and chloride is anion. It is properties of ionic compounds. So, as you can see in table 3.4, it shows some ionic compounds, their melting point and boiling points are given there. Now, as you can see, it is quite high. Both the melting point and boiling point is very high in this case. So let's see what are the properties of ionic compounds. So ionic compounds, first property is physical nature. They are quite solid and they are quite hard because of strong force of attraction between them. So as you know, we have some ionic compounds as the most common ionic compound is NaCl. In that we have seen that we have Na plus and we have Cl minus. So because of positive and negative ion, they have strong force of attraction between them. So therefore they are quite hard and these compounds are generally brittle as well and break into pieces when pressure is applied. If you apply pressure on ionic compounds, they will broken down into pieces. Now the second is they have high melting and boiling point. Why they have a high melting and boiling point is because they have quite strong interionic attraction between them. So therefore they have high melting and boiling point. These are the very important questions from the viewpoint of board. So third one is solubility. These electrovalent compounds or ionic compounds are generally soluble in water. Their solubility is high with water, but not with solvents such as kerosene and petrol and so on. Then the fourth one is conduction of electricity. Now, one important thing here is that ionic compounds in solid states do not conduct electricity because there is no movement of ions in it. Now, if this ionic compound is like in liquid state, then they can conduct electricity. Like, it is also known as molten state. So, if this compound, the ionic compound, is in like molten state, then it can have some charges which can actually cause conduction, and these ions are actually helpful in conducting electricity. So if ionic compound is in water, therefore it can conduct electricity. If ionic compound is in solid state, it cannot conduct electricity because there won't be any movement of ions in it and their structure is quite rigid. So you must remember these 2 points as it is very important from the viewpoint of like expand and then they say give reasons for it. So these are the 4 points which are very important under properties of ionic compound. Let's start with next topic. So we have occurrence of metals. Like where do we get metals from? So major source of metal is earth crust. Now some elements or compounds which occur naturally on the earth crust is known as minerals. Those elements or compounds which occur naturally in the earth crust are known as minerals. Now these minerals are often known as ores. We get minerals from ores. Now they are in combined state most of the time. So let's see how we can extract metals from it, pure metals from it. So as you know, we have a reactivity series of potassium, sodium, then calcium, then magnesium, then aluminium, then zinc, Fe, Pb, Cu, Ag, Au. Now these are the metals at high reactivity. They are quite high reactive. Then this has been categorized into medium reactivity. Then the last one is in low reactivity. That means least reactive. Now let's see how we can actually get these from, like how we can get these into pure form. So as you know, high reactive metals are quite reactive. That means they would be reacting with any other element or any other gases in environment. So let's see how to extract metals from high reactivity. So actually we can make use of electrolysis of molten ore. So we can do electrolysis if it is in molten ore. Molten means liquid form. So if we do electrolysis of any ore which is in molten state, we can get pure metal directly. So for high reactivity, for like elements such as potassium, sodium, aluminium, they can be electrolyzed to get to have into form of pure metal. Now, if we have metals of medium reactivity, they are obtained from two ores, that is carbonate ore and another is sulfide ore. So if you get from carbonate ore, then you have to do calcination. If we have from sulfide ore, you have to do roasting. So these are two processes by which we can get metals of medium reactivity. Then from calcination and roasting, we get oxide of a metal. Then for oxide of a metal, we have to do reduction. Reduction is with the help of carbon element. Then from it, we get purified metal. So remember, from metals of medium reactivity, we have different types of ores, that is carbonate ore and sulfide ore. Carbonate ore, if you want to get oxide of metal from carbonate ore, you have to do calcination. If you get oxide of metal from sulfide ore, you have to do roasting it. Then oxide of metal can be reduced by the method of reduction, and then we get purified metal. Next is metals of low reactivity. Metals of low reactivity are generally in native state, that means are in free state, but some of the time they are with sulfide ores. We get them from sulfide ores. So again, as I told you in the case of metals of medium reactivity, for sulfide ores we have to do roasting. Then we get the metal and then we have to do refining of it. Refining means we have to refine it. If any other impurities are there, then we can remove that. Now the next topic is enrichment of ores. We basically have to study what are the enrichments we have in ores. So like we talk about impurities in this. So as we can read the first line, it says ores mined from the earth are usually contaminated with large amount of impurities such as soil, sand, etc. And that impurity is known as gangue. So the impurities must be removed from the ore prior to the extraction of metal. So basically we have to remove these impurities from our ores to have pure metal at the end. So let's start how we have to extract metal from the low in the reactivity series. So first of all, we have HGS. HGS is actually a cinnabar. It is actually ore of a mercury. It comes into 1 mark question like what is the ore of mercury? It is cinnabar and you have to write HGS for it. Now next is how to get pure Hg from HGS. So you have to burn HGS in the presence of oxygen and you have to burn it, then you will get metal oxide. So it is very important. We have ore first, then we get metal oxide here, that is mercuric oxide. Then we have to reduce this mercuric oxide to mercury, that is the pure element, the pure metal we have. So it is Hg. He plus oxygen. So I hope it is clear. So we have a ore that is cinnabar. Cinnabar is HGS. Then you have to burn it in the presence of oxygen or you have to heat it. Then you will get the metal oxide. As you can see, it is HgO here. Then HgO needs to be burned to get mercury. So mercuric oxide being reduced to mercury on further heating. Now similarly for copper it is given here. So for copper, which is found as copper sulfate in nature, can be obtained from its ore again. So as you can see, we have copper sulfate. When on heating we get copper oxide, and copper oxide on heating we get copper as element. So we get a proper element, that is copper, that is pure element copper. Now if you want to extract metals in the middle of the activity series, as I have earlier discussed with you, so it is, we get metals in the middle of the reactivity series as a sulfide ore or the carbonate ore. So as you can see, for roasting, you can see here one example is given, that is with respect to zinc sulfide. So zinc sulfide when reacts with oxygen forms zinc oxide and sulfur dioxide. So when sulfide ores are converted into oxides by heated strongly in the presence of excess air is known as roasting. So remember this, whenever we have a sulfide ore, that is zinc sulfur in this case, in the presence of oxygen gets converted into zinc oxide is known as roasting. Then we have calcination. Calcination is when carbonate ores are changed into oxides by heating strongly in limited air. This should be done in limited air, and this process is known as calcination. So this process is very important, like they ask you difference between calcination and roasting. So you can write in roasting that it is done in excess air, whereas in calcination it is done in limited air. Then if you want to reduce metal oxide, it should be done with the help of reduction. Reduction is done with the help of carbon. So if carbon is there, it will displace zinc from it and take carbon dioxide with it, carbon monoxide with it, sorry. So as you know, because carbon is more reactive than zinc, so it will displace this. So this is even known as displacement reaction, or it is actually oxidation and reduction process as well. So this is for extracting metals in the middle of the reactivity series. Again, some examples are there, and this is very important. It is generally asked in question paper, like what is Thermite reaction. So Thermite reaction is actually done in the case of joining railway tracks. So basically, they use aluminium. The amount of heat here, like you can see, we have Fe2O3. It is actually a iron oxide, and when iron oxide is reacted with aluminium, it forms iron only. So iron and aluminium oxide. So this metal actually evolves so much of heat that it is known as Thermite reaction. And with the help of heat, they join these railway tracks. Then we have extracting metals towards the top. Top of the reactivity series, as you know, has most reactive metals. So we have to do it with the help of electrolysis. So we would be doing electrolysis here. This is for copper. As you can see, they have taken copper sulfate solution as in molten state, and copper sulfate is there. That means copper will have positive charges and sulfate will have negative charges. So copper will be actually attracted towards cathode and sulfate will be attracted towards anode. So on the cathode, we will have a strip of pure copper. On passing electric current, pure copper is deposited on the cathode and impurities get on anode. So this is actually the whole process. So as soon as you pass the current through the electrolyte here is copper sulfate solution. So the pure metal from the anode dissolves into the electrolyte. This whole part, as you can see, there is some impurities as well. The anode mud is known as impurities. So an equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. So remember this, we have impure metal is made on the anode first, then we have a thin strip of pure metal at cathode. Now we have a metal salt is used in an electrolyte. Whatever metal you want to have should be used as a electrolyte for you. So on passing the current through this electrolyte, we have two ions, that is copper and another is sulfate. So the copper one will be more attached to cathode as it is a positive ion. So it will be more towards cathode and the negative one will be towards anode. So it will be a pure metal that is deposited on cathode, whereas this anode mud is actually the anode impurities. Last topic is corrosion. So in this, you have learned the following about corrosion in chapter 1. So the first one is about silver. So when silver articles exposed to air, they become black. So this is because when it reacts with sulfur in the air to form a coating of silver sulfide. So when silver reacts with air, then it forms silver sulfide, because if it is in the condition of like reacting with air, then it might be interacting with sulfur as well. So when silver combines with sulfur, they form silver sulfide and it is black in color. So from silver, it gets converted into black color. Now the second is of copper. So copper, when reacts with moist carbon dioxide in the air, they slowly loses its shiny brown surface and gains a green coat. So when copper reacts with moist carbon dioxide, they form copper carbonate, and this copper carbonate is of green color. So when copper reacts with carbon dioxide in the air, it forms copper carbonate, which is in green color. Then we have the third one, iron. Iron is when exposed to moist air for a long period of time, it acquires a coating of brown flaky substance and it is known as rust. So this is what we need to study in this topic, that is rusting. Iron substance when exposed to air and water simultaneously, they gets converted into iron oxide. So let's study about this. So here we have activity 3.14. In this we have three test tubes A, B and C. In the first one we have air as well as water is there. When we have air and water, therefore it is meant to be rusted. So the iron be rusty in this case, you can see. In the second one we have water, but there is some layer of oil which can prevent this air to go into this water. So therefore these irons will not be rusted. In the third one we have dry air, sorry. So dry air is actually anhydrous calcium chloride, which is actually a drying agent which can dry off all the air present in this test tube. So therefore these iron nails will be intact here. There won't be any effect on this. So the only effect is in the A test tube. Now the second is how to prevent corrosion. So the basic concept of this is like we want to stop corrosion on the iron. So the first is painting. You can do paint on the substance of iron, made up of iron. Then you can do oiling or you can do greasing. Then the fourth one is galvanizing. Galvanizing is when you have iron and you put a coating of zinc on it. So basically if you have iron material, you want to have a coating of zinc This process is known as galvanization. It is done to protect steel and iron from rusting by coating them with a thin layer of zinc. Now, the galvanized article is protected against rusting even if the zinc coating is broken out. Now, the next is chrome plating, that is also known as electroplating, and the last one is anodizing, or you can say making alloys. So, chrome plating is done with the help of electricity method, and the anodizing or making alloys is a method to make use of two metals to make a better method to make a better metal out of it. So basically to improve the properties of metal we make alloys. So if I say like iron, when mixed with nickel and chromium we get stainless steel, which is quite hard and does not rust easily. So therefore it is very beneficial to add nickel and chromium into iron. So therefore they change the properties of particular metal, and this process is the best one out of all. So even you can make alloy with the help of metal as well as non-metal. So this is actually prepared by melting first the primary metal and then dissolving the other elements in it definite proportion, and it is then cooled to room temperature. So if you know, in the bracket, do you know, you can see it talks about pure gold. So pure gold is actually of 24 karat gold, which is quite soft. So therefore we can't make suitable jewelry from it. So therefore in India we make use of 22 karat gold. It is actually alloyed with silver or copper to make it hard. So basically they mix silver and or copper in pure gold to change the properties of pure gold. So therefore we can make ornaments out of it. Now the next is, if one of the metal is mercury, then the alloy is known as amalgam. Remember this. The electrical conductivity and melting point of an alloy is less than that of pure metals. For example, brass, an alloy of copper and zinc. So remember, brass is made up of two elements, that is copper and zinc, and bronze, an alloy of copper and tin, are not good conductor of electricity, whereas copper is used for making electrical circuit. So as you can see here, if we mix something in copper, it becomes a bad conductor of electricity because their properties are now changed. So if we are using single copper, then it would be a better conductor of electricity or can be used as electrical circuits. So therefore, it is better to change the properties of these alloys to make better use of these. So that's all in chapter 3. We will continue with the next chapter in next class. Thank you for watching this video.